This video is a quick revision video on the national grid. And the clue a question would be about national grid is you'd either get a picture involving pylons, power station, transformers and a house, or you'd see the words national grid. And what national grid is, it transports electricity. So for example, we start off with power station, and let's say for example the power station generates 50 megawatts of power. Mega meaning times by million, so 50 million watts. We want to transfer that to our domestic houses. So how do we do that? First of all, we have to use a step up transformer. Step up transformer. And what that does, step up transformer increases the potential difference. Obviously don't use the arrows in PD, this is just for illustration purposes. Increase potential difference, which decreases the current. And that decreasing the current is really important, because if we decrease the current for the transmission cables, so I'll just label these up for you. So you could call them transmission cables, you could call them power lines. If we decrease the current, we get less energy wasted as heat, less energy wasted as heat or as thermal energy, therefore more efficient. You don't need to remember the potential that it's transmitted at, but it's about 400,000 volts, which is far too much to go into our schools, hospitals and houses. So what we use is we use a step down transformer. Like the name suggests, step down transformer decreases the potential difference and it increases the current. And it decreases the potential difference to 230 volts for our mains electricity supply, and that's for safety reasons, nice and low. And this next bit of the video is for higher tier only. To calculate the energy wasted as heat, we use the power equals current squared times resistance. And the power wasted is equal to the current squared times resistance. So if we decrease the resistance, we get less power wasted. That's why we use metals with very low resistance, so it don't get hot or don't get as hot, so we lose less energy as heat, therefore it's more efficient. And we use a step up transformer to decrease the current. If we decrease the current, we get less power wasted. For example, if we had a current of 30 amps and a resistance of 1000, 30 amps squared times by 1000, 30 squared times by 1000 equals 900,000 watts wasted. 900,000 watts wasted. But if we decrease that current to 3 amps, the resistance of the cable stays the same, so times by 1000. How much have we got wasted this time? So just change my calculation from earlier. So instead of 30 squared, now I've got 3 squared, we've only got 9,000 watts wasted. By decreasing it by a factor of 10, we've decreased it by a factor of 100, because decreased by 10 times, 10 squared equals 100, so it's decreased by a factor of 100. So decreasing the current, less power wasted, decrease the resistance, less power wasted. So national grid summary: step up transform, increase potential difference, decreases the current, less energy wasted as heat, therefore more efficient. Then the electricity transferred to step down transformer, where the potential difference is lowered to 230 for safety reasons for our domestic use, and it increases the current.